it's a little bit odd for me, in a way, to see Nervi as engineering history. There he absolutely is, because I guess quite a lot of the people in the audience, found his structures really inspiring when in those days I was havering between being an engineer and an architect. But seeing examples of his work and of Torroja and Felix Candela and other people, you suddenly thought, well, maybe it could be quite fun being an engineer. I've never done anything of any real scale, but that doesn't stop you admiring things of very considerable size. And it was nice seeing the section of the Palazzo della Sport on the screen when we came in. I was trying to remember why, when on my first ever visit to Rome in 1967, one of the things I did was go out through, I think it's the Porta Flaminia, to find the Palazzetto. And it wasn't officially open, but I still managed to find a door to get in, as I suspect many visitors to the building have done since. But what struck me then was something you said in your book, Tom, which is that while the structural form is wonderfully clear and has this real elegance and hierarchy to it, the way that the changing rooms and WCs and so on are slotted in doesn't match. It's not on the same scale. It's not on the same sort of wavelength at all. And that gets, I'm afraid that's true for a lot of his buildings. But in a way, at least the structural detailing is beautifully executed. Whereas if you go and see some of Calatrava's buildings, the architectural detailing is wonderful, but sometimes the structural detailing is just awful. And somebody once asked me what I thought of Calatrava's work, and I said, well, it's always profligate and it's sometimes elegant. Now, Nervi was not profligate. He was out of the same mold as Robert Maillard and people like that, who took economy as a real constraint, but as a positive constraint, as something that, if pursued remorselessly almost, would help you as an engineer generate something that was truly elegant and had a beauty all of its own. And so his structures are wonderfully detailed and thoughtful. Anyway, without more ado, I'm very happy to hand over to Professor Thomas Leslie, who's going to talk about Nervi tonight. When you had your book published on Nervi, was it a conscious genuflection to the format of aesthetics and technology? It was good. No, I'm glad. As those of you who try to read Nervi's book on the aesthetics and I can't remember the full title now, but it's a landscape format book, quite long and slim, and it's not actually very easy to hold in your hands. And Tom's done the same. Anyway, very much looking forward to it, Tom. Thank you very much for coming to talk to us about bellezza architettonica. Okay.
Well, thank you very much for that kind introduction, and it is indeed a great honor to be asked to deliver the Sutherland lecture this year. I love this idea of active history. I'm going to steal the phrase shamelessly. My own background is in practice. I'm an architect. I worked for Foster and Partners for many years, 3 of them here in London. And when I decided to embark on a teaching career, the administration at Iowa State asked if I could teach structures to architects, and I lied and said yes, and have enjoyed the sort of challenge of trying to kind of knit together these two realms ever since. My research, I like to describe it as history with its sleeves rolled up, which I think is maybe a sort of American way of saying active history. That I'm interested in the stories that come from the drawing tables and from the job sites, about this sort of labor, both physical and intellectual, that goes into making buildings. And in particular, what happens when that labor is sort of distilled or refined by constraints that most of us would regard as sort of impossible. And so I sort of gravitate towards figures like Nervi or Lucan in an earlier research project, who take the engineering of buildings and also the construction of buildings seriously, and try to use them as both inspirations and also sort of productive constraints on their design. So this project on Nervi, it's also true to say that most of the figures I'm interested in came out of discussions that I had with people at Foster's, right, looking for the inspirational figures and trying to see if there was a history to the sort of work that Foster's and other firms do. And Nervi was a constant discussion point, constant reference point for us. He needs no introduction probably to this crowd in general. His name is on the wall to my right, and justly so. But my interest in researching him was to see if there was a sort of untold story. And what I kept going back to is this description of Nervi as a quote-unquote poet in concrete. And this was the way the popular press always described him. And the sort of insinuation was that Nervi was this sort of genius figure. He had this insight that no one else had, and therefore he was able to make these sort of incredible structural leaps that other engineers, other architects and builders couldn't do. And the research that I've done, I think, hopefully dispels that myth and shows that Nervi certainly was brilliant and very talented, but that this was not some otherworldly ability, that this came actually from the very nuts and bolts, the kind of very hard facts of engineering and construction. And so what I'd like to do tonight is to give sort of a précis of the book, of the research, and to show how this great figure's career was grounded in these very, very pragmatic aspects of construction and engineering. And then toward the end, I want to sort of turn it around a little bit and to suggest that maybe calling Nervi a poet in concrete was exactly right, but for reasons that have more to do with how we might think about the term poetry and less to do with Nervi as a sort of otherworldly figure. The way that I typically talk to students about Nervi is to show these two images. And on the right, this is Nervi's Palazzo in Rome, and I can attest that you can still sneak in successfully. It's the best way to do it. On the left is a building that superseded it in span in Seattle, the Kingdom, which was another sports arena that was built just a couple of decades later. And putting these two together, I say, look, one of these buildings is relatively small. The other one is huge, a record-breaking span. One of them is much beloved by everyone who walks into it, engineer, architect, sports fan. The other one was demolished just 25 years after it was built because it was so unloved, right? So sort of unbeautiful. And an incredible achievement. But the difference between these two, I think, is worth considering. And so my goal here is to talk about why the building on the right sort of grabs our attention and holds it and sort of compels us to engage with the building and to think of the building as an experience, while the building on the left did no such thing, right? What's the difference between the two? And in studying Nervi, I think that the crucial thing to understand is that he came essentially from two worlds. He had two offices in Rome. One of them on the left was his engineering office, where he worked with a relatively small studio, a dozen, 24 engineers and draftsmen at most. He lived, quote unquote, above the shop. That's his apartment on the top floor. The office is on the ground floor. But he had a second office, a sort of construction yard in just south of Rome, in Maliana. And here he would go and he had another crew, another group of employees who were laborers. And here he would experiment with techniques in concrete. And on the right you see maybe one of his better known of these experiments, a warehouse built of folded ferrocement plates. And so there are these two aspects, right? Engineering on the one hand, construction on the other. And I sort of picture him going back and forth, having an idea with his sort of necktie on and white shirt, and going down to the job site in the afternoon and sort of testing those ideas out. And he came by this sort of dual focus quite honestly. As a student at university in Bologna, he cited two figures as having profound influences on his development as an engineer. Silvio Canavazzi on the left was one of the great early theorists of reinforced concrete. And you get the sense from looking at them, he was an academic. He didn't practice. He was more of a mathematician than a practitioner. And on the right, Attilio Muggia, who was a local contractor who taught concrete construction and taught it from a very pragmatic, practical point of view. Nervi went to work for Muggia after graduating, and always sort of credited this sort of twofold focus with informing the way that he thought about construction going forward. He never thought of engineering and construction as being divorced, but rather they're part of the same discipline to him. Now, Nervi graduated just before the First World War and ended up practicing in the 1920s, beginning his practice in the 1920s. And the other thing that I think it's crucial to understand about Nervi's career is not just the sort of inspiration that he had from his academic upbringing, but the very, very unique set of constraints that he faced as an engineer and builder in Italy in the 1920s and 1930s. One of the most sort of surprising things I've found going back and looking at the sort of building climate or the building culture in Italy when Nervi was coming up is that Italy is actually quite starved for natural resources. And as you see here, these two maps, I think, speak to this quite well. This is a map of the sort of iron ore resources in Europe and the coal resources. And both of these, of course, are vital for producing iron or steel of any kind. Now, ordinarily, this wouldn't be so great a problem. You would import the steel, you would import the coal. But in the 1920s, of course, Italy falls under fascism. And as Mussolini begins to sort of violate the norms of international protocol, the country becomes more and more isolated politically and then economically. And by the end of the 1920s, it's embargoed, and Western countries aren't allowed to trade with it. And what happens is Mussolini starts a policy of what he calls autarky, or self-sufficiency, where the only materials you're allowed to use are sort of native Italian materials. And what he means by this, of course, is travertine and marble and brick and concrete, the sort of great Roman materials. Timber is another scarce resource. The deforestation that had happened on the Italian peninsula at this point for a couple thousand years meant that even traditional building materials were somewhat scarce. So Nervi is under pressure to build without steel, without even reinforcing steel. And after a brief period during which he led the syndicate of engineers in Florence, he had a break with both the syndicate and with sort of the fascist approach to autarky in general. And a few years later wrote this very brave editorial in a Roman newspaper called For Autarky, in which he made the case that this emphasis on brick and travertine and marble was really counterproductive, that to make the brick, you still needed to import fuel, and that you needed so much marble or travertine or brick or concrete that it made much more sense to use what little steel you could find in the smartest, cleverest way, to stretch it as far as you could, and to use the sort of vanishingly small amounts of steel to actually stretch materials like concrete as far as possible. And his point here was that reinforced concrete, if you wanted to be really autarkic or really self-reliant, that reinforced concrete really was the material that you wanted to turn to, not travertine, not brick. And he had some early successes in reinforced concrete that sort of proved his point. Long before he wrote the article in 1938, he and his cousin, and then after splitting with his cousin, his business partner in contracting, built these two grandstands for the Florence Football Club, Fiorentina. The one on the left was the first one, initially sort of the more famous of the two, and it has this famous cantilevered span with these gracefully swooped supports that has a fair amount of reinforcing in it, but generally relies on the strength of concrete to achieve that cantilever. And Nervi's point was this is what a truly self-sufficient, truly autarkic structure should look like, where you are engineering the concrete so that you're using as little of it as possible, as little fuel as possible, and you're using reinforcement as wisely as you can to sort of stretch that material. With Bartoli, who's a slightly more experimental contracting partner, he builds this second stand a year and a half later that features these very, very graceful helical staircases. And Nervi here is not only trying to find an economical solution to a very real circulation problem, how do you bring people from under the stands and have them enter from the back instead of from the front, but he's also finding ways to do this efficiently. And increasingly, he's interested also in expression, in finding ways to solve these problems that are not just pragmatic, but that have some visual impact to them. These two structures gain him a lot of press. The grandstand, unfortunately, is wrapped in a very sort of staid, very fascist facade, so you don't actually see the cantilever until you're in the stadium. But the stairs, being on the sort of cheap side of the stands, still stand today just completely revealed. And Nervi clearly here is realizing that there are architectural possibilities or aesthetic possibilities within these very, very constrained circumstances. So perhaps most famously the experiments, the projects that Nervi did for the Italian military as the country was descending toward World War II in the late 1930s. The Italian Air Force by 1937 was sort of desperate for solutions to storing its aircraft that didn't use steel, because by this point steel was almost impossible to get. They couldn't build them out of timber either. And so they put a tender out to the country's engineers to look for ways to build aircraft hangars out of concrete. And Nervi responds with a scheme that employs about 3 or 4 different structural ideas, all sort of compressed onto one. So this first set of hangars at Orvieto is a vaulted roof, so a relatively good structural shape to begin with. It's rendered in this lamella grid, so diagonal ribs that self-brace one another and allow the vault to take both gravity loads and lateral loads. I tell architects when I'm showing this that it tricks the vault into thinking that it's deeper than it is. I realize that's a laughably simple explanation to this crowd, but it works, right? Architects sort of get that. And then you'll see around the base, the vault is lifted up in the air on about 36 buttresses, most of which go around the back, and 3 of which are at the front to allow planes to move in and out. And the thrust of the roof is actually taken by this horizontal truss that you see spanning along the right-hand side of that image. Nervi builds 2 of these. They are dramatically successful. They have some thermal expansion problems that he solves slightly clumsily, but they generally work, and the Air Force is encouraged by this. They realize that it is possible to build such a lightweight, long-span structure out of concrete. They're also published widely, including in the United States, and these are some of the first projects where Nervi gains a reputation not only as an engineer, but also as someone who's able to create these works that are sort of strangely beautiful, right? The architectural press kind of takes an interest. Nervi, however, is not so pleased with the results. And later on, he writes that he sees 2 problems with these hangars. In the first case, he says that because they rely on monolithic behavior, he's had to go and actually build the building twice. He's had to scaffold and form it out of timber, and then he's had to come back and actually pour the concrete. And timber being not quite as scarce as steel, but still quite scarce, he realizes that this is a waste, that he's essentially thrown out a whole building's worth of timber to create this formwork. The other problem that he sees is pretty evident from the construction photo on the right. This is where the joint where 3 of these ribs come down and actually meet one of the buttresses along the back side of the hangar. And he says that even though he's used reinforcing steel to kind of extend concrete as far as he can, by the time this very relatively heavy concrete shell comes and sits on the buttresses, the forces are so great that he's basically designing a steel hangar with sort of concrete painted on the outside. And the Air Force doesn't quite realize this, but Nervi is genuinely embarrassed later in his career to show this image and to say that even though this appears to be a concrete building, when the vault comes down near to the buttresses, it really is more of a steel building. And so he's determined to try to solve these 2 problems. How do you not waste all of that formwork, and how do you reduce the weight of the roof shell so that you're not having to provide so much steel to take the forces as they come down? And it's here that Nervi sort of switches from, I would say, being a more purely structural engineer to being to more of almost a contractor and trying to think through these hangars as a problem in execution instead of just in design. Over the course of the next couple of years, the job yard in Maliana is full of these experiments where Nervi tries to precast arch forms that will take the place of the poured-in-place lamella grids that he's made at Orvieto. And his reasoning is that if you precast these, you can achieve much tighter tolerances in a precasting yard than on site. And therefore, you can create shapes that are more efficient. So you can remove the kind of dead weight or the concrete that's not doing its job quite so efficiently toward the middle of the members. And you can also sort of telescope the amount of time it takes to build the foundations and the supports with the amount of time it takes to fabricate the arches themselves, that you can do them both at the same time, and thus not only save in material, save in formwork, but also save in schedule. And to me, one of the most interesting drawings that I ran across is this one in Nervi's archives, where he's thinking about 3 things at once. In the lower left, he's thinking about the plan of the hangars, right? The grid of the lamellas that will go over them. On the right, he's thinking about the shape of those individual precast units that form the arches. And then in the upper left, he's thinking about ways to take those precast elements and to make them behave like a monolithic shell. And what you're seeing there on the corners of that octagon are 4 precast truss members. Each one of them has a loop of reinforcing steel that sticks out of it. And the octagon is actually a small plug of reinforced concrete that he'll pour to actually hold those 4 elements in place together to create a monolithic joint out of 4 discrete precast elements. This experiment in the Maliana yard is sort of the proof of concept, and you can see that he's now using Virandeel truss elements, and he hasn't yet poured the concrete to sort of weld them together, or to connect them together monolithically. But you can see that these are being supported on a very, very light set of wooden scaffolding. And of course, there's no formwork. The formwork has been placed on the ground, and it's been reused again and again and again to create each family of similar truss shapes. And this principle of prefabricating the elements and hoisting them into place saves weight because the shapes can be more efficient, but Nervi realizes that it also saves construction cost. And later in his career, he taught structures to architecture students at the university in Rome. He has this, I think, a really telling definition of construction. And he says that the fundamental problem in construction is moving weights, lifting heavy things into place. Nervi's contracting firm is relatively small, a small group of laborers. He doesn't own his own equipment. He has to go and rent the cranes and hoisting equipment for his job site. And he realizes that if he breaks the building down into smaller and smaller pieces, he'll save money on renting the cranes themselves, and that's a substantial amount in his budgets. So prefabrication not only allows him to do more effective shapes, but it also saves him money on the hoisting equipment that he has to rent. This is the Corsa Francia in Rome, where you can see that he's broken the scale of this highway viaduct down to spans that he can use a relatively small crane for. And here that building is today. And you can maybe see where this is heading, that this has a scale to it, a sort of human scale that most highway viaducts don't, because Nervi is under the constraints of having to use these small pieces of equipment and therefore having to break his spans down into smaller and smaller elements. So in 1939, he wins a tender for another set of hangars, these on the Italian coast. And he proposes to do them using exactly this method, to precast all of the elements on the ground while the buttresses are being built to support the roof, to hoist them into place using very lightweight equipment, and as you can see in the background, to use a traveling scaffold that will allow him to place each of these, to pour the small quantities of concrete, and basically to have that scaffold just move down the job site almost like an assembly line, right, leaving behind the hangar roof as he goes. That's Nervi in the front there, looking fairly satisfied with himself, behind one of these truss elements. And on the right, you can see what I think is another sort of critical moment in Nervi's career, where for the first time he looks at the building almost finished, and instead of just documenting it as a sort of through this sort of typical job site photographs, he commissions Studio Vasari, which is Rome's finest architectural photographer, to come to the site and to take pictures of the structure before the roof is put on. And that, I think, is an interesting moment where Nervi realizes that almost by accident, right, by taking so seriously the constraints of the structural problem, and by distilling those through this kind of language of the job site, he's created something that has a kind of architectural nature to it, right? That he's created something beautiful out of these very sort of rudimentary ideas about structure and precasting. And as evidence for this, I submit that the drawings for this project, they're only partial in the archives, but there are three types of drawings for this second set of hangars. There are, as you can see on the left, beautiful hand-drawn graphic statics calculations for every single rib and juncture around the base of the hangar, calculated by hand, obviously, in 1939. In the upper right, you can see scaffolding drawings where Nervi is laying out the geometry of the roof and then laying out the scaffolding that he will need to build it. And on the lower right is a shop drawing, essentially, for the truss work. There are almost no drawings in the office of what these hangars were going to look like. There was no sort of intent to think about them visually or to think about them as pieces of architecture. Nervi designed the process. I think he had some subtle bits of intuition along the way that maybe tweaked things just a little bit, but at the end, this process leads to this very, very dramatic work of almost pure aesthetics, right? Something that Studio Vasari comes out and takes photographs of. There's one more wartime experiment that I think takes this sensibility to even a greater level. And that's this rather desperate commission that the Italian Navy gives him in 1942. Even more than the Air Force, the Italian Navy is under pressure to build ships, but to do that without timber and without steel. And like the Air Force, they go to the country's engineers and they say, is it possible maybe we could build ships out of concrete? And Nervi says, of course. And he's given a shipyard that has no hoisting equipment, no electricity, and no power, and is told we need 3 of them in a hurry. And he actually builds these 3. And the secret turns out to be taking advantage of the one resource that he does have access to, and that is labor, and particularly unskilled labor that is migrating from southern Italy through the peninsula during wartime in search of work. He adopts an old French technique that in Italian is called Ferrocement, where you take thin sheets of metal mesh, which is a fairly cheap, fairly easily obtainable material even in Italy, and you lay those layers on top of one another and then impregnate the results with a very lightweight sort of zero aggregate cement. And you wait for that to cure and you're left with a very thin material that behaves somewhere between concrete and steel, right? Not as thin as steel, not as ductile as steel, but also that's able to take a fair amount of bending loads. He takes very minimal amounts of rebar, bends them around jigs, and then sets loose a small army of laborers to just simply trowel cement into the resulting shapes. And as a result is able to build these concrete hulls with, again, no hoisting equipment and no power on the job site or in the shipyard. And this Nervi speaks about as sort of the other great lesson to him, that prefabrication lets him save weight and lets him save time, but ferrocement actually allows him to take that weight savings and double it. And he says, talking here about the Stadio Flaminio, where he adopted the technique for these sort of flying roof forms, he says that, if you were to do these just out of prefabricated concrete, you would be left with a minimum of 3 inches because you need the space for the rebar and then you need protection on either side. But with ferrocement, you can actually reduce that to 1.5 inches. And so you're taking the savings that you already had with prefabrication and you're essentially doubling them, right? You're halving the weight again of the finished element. You can make these in much more refined shapes. If you look closely, you can see, maybe not so much here, but in the construction photo, you can see that these blades for the Stadio Flaminio roof start in a very deep hollow wedge at the root and then taper to a very flat blade at the tip. Right? So perfect cantilever shape, but sort of spread out in these curving forms that cover the grandstands as well. And as you can see, he is tied to the economy of this, right? He has to rent the cranes, and so he's sort of forced to save more money than any of his competitors, and therefore wins the commission. So the first moment where Nervi takes these wartime experiments and really applies them to a building comes in 1947. When the city of Turin agrees to host the International Automobile Exposition in 1949. And this is an exposition that Turin has hosted before. They're the home of Fiat, so they're sort of the automotive center of Italy. But Turin, of course, is devastated in the war. It's one of the most heavily bombed cities in Italy. And their exposition center, along with much of their industrial capacity, has been utterly destroyed. The good people of Turin say, that's fine, we'll build a new one and we'll give some lucky firm 8 months to design and build a whole exposition center. And Nervi and Bartoli are the one firm that accepts the challenge and bids on the job. And what Nervi decides to do is to take the sort of lessons of the shipyard and to create, instead of large ship hulls, to apply the lessons of prefabrication from the hangars and to instead create these little tiny sort of boat-shaped elements. I think of them as canoes or sort of kayaks. They're that sort of scale. Using ferrocement, using those teams of unskilled laborers to just turn these out almost as an assembly line while he is pouring the foundations and the supporting structure for the exposition center. Once these are all finished, he develops a process where each one of these little boats will be lifted up into place and sort of slid down on a rail, grouted to the one immediately adjacent to it, to form these long, low, folded plate arches. And again, there are 3 or 4 structural principles at work here. Overall, it's sort of a 2-hinged arch. If you go in the other direction, it's a folded plate of very, very thin ferrocement. So 3 or 4 ideas getting sort of put together to create this one super efficient, very thin shell roof. And as you can see on the left, he realizes that he doesn't even need a crane, that every one of these pieces is actually hoisted by a winch using human labor to bring it up, and then human labor again to just slide it down into place. So this is a huge exposition hall that's built entirely by hand labor. And here's the result. It opened on time, on budget, hosted the auto show, and Nervi, speaking about it, professed to be almost sort of baffled that it was also so beautiful, right? That it was such an amazing kind of space inside. I would argue that I think what you're looking at here is not just the span itself, but you're looking at the span and the kind of the pattern of its execution, right, and its fabrication, and that there is almost like a human scale that's been imprinted onto this otherwise sort of sublimely large space. Now, there is one complication that would prove sort of critical to the next stage of Nervi's development, and that's the half dome that you see on the right of the slide. Nervi tried very hard to convince the clients that a half dome was a crazy shape to try to build out of concrete structurally, that the thrusts at the corners in particular were just going to be too great, and it was too complex a geometry to handle. But the client said, no, we need this kind of apse, the kind of court of honor. Here's the plan. You decide how to build it. And as you can see, there are really these two separate halls. There's the very efficient extruded arch of the main hall, and then there's this apse around the back. And you'll notice that the apse has this very striking kind of radial pattern, almost like a sunflower. And this was the result of Nervi's realizing that if he had a ferrocement yard going anyway, he could be manufacturing the structural components for one roof, and he could be manufacturing formwork for a thin shell that would cover the other roof. And so he set to work, having his team build hundreds of what he called tavelloni, or little tablets. These are diamond-shaped pans, each one about sort of a meter by a meter. And as you can see, they're very thin, and they're formed out of the same ferrocement that the roof elements of the main hall were. They're designed to be basically coffers. So this is essentially just a super fancy waffle slab that instead of being laid out on a flat surface is laid out on a curved or domed surface. On the left, this is workers building ferrocement pans for an adjacent hall, Hall C. On the right, you can see these diamond pans have been laid out to tile that half dome. As a result, once concrete is poured over the backs of these, the pans are left in place, the joints are grouted, and you then get this pattern of ribs, again, just like that first set of hangers, stiffening a very, very thin shell of concrete behind it. And because the weight is so much less, the thrusts are less, and therefore he can get the half dome to work. He says later in his career that this is still a crazy form to try to build, but if the kind of architectural impulse is to have you build something that's crazy, you at least have to find the most rational way to do it. This idea of using ferrocement not only structurally but also as formwork is an idea that he uses in a number of different ways. And a couple of, I think, his most interesting and most underrated buildings use exactly this technique to build factory slabs. This is a factory or a warehouse in Bologna that he built for the state tobacco interest just after the Turin Hall was being finished. And you can see on the slide on the right that this is essentially a waffle slab, and those are just domes, just like we would use today in a simple waffle slab. But they're ferrocement, and therefore you can see that Nervi can make them any shape he wants, right? You build a mold, and you can shape mesh and put cement into any shape you want. These domes are then put onto this machine that you see on the left that I think of as almost kind of a building machine, right? That just drives down each subsequent floor, kind of imprinting a concrete slab above it. But the result of this is, I think, a really subtle detail. You can see that because of the curved shape of the pans, the joists for this slab all sort of flare out gently as they approach the girder. And Nervi writes about this as acknowledging the fact that the shear stresses in those joists get just slightly greater, right, as they get toward their supports. He says, of course, the easiest way to do this is just to add a little bit more reinforcing steel. He says nobody in a tobacco warehouse is likely to know this, but he's kind of having fun, right? That this is a way that he's sort of signing what would otherwise be a very sort of prosaic building. It's a detail that I think is kind of genius for the small scale of its intent. more famously is a wool factory outside of Rome, where he uses ferrocement pans to express a kind of larger structural idea, which is the isostatic diagram of stresses in this two-way slab. And so you can see the pans are quite elaborately shaped, but because they're used again and again and again, and because they're molded from one mold, he can make them any shape he likes. And as more recent critics have pointed out, this is the isostatic diagram for a flat slab, and once you turn that flat slab into a ribbed slab, the diagram changes dramatically. And so this is purely ornamental. Right? This is not really doing anything that a simple waffle slab would not. Again, I think it's Nervi kind of signing the piece almost, right? Using a constructive technique to reveal something about the statics behind it. So the greatest kind of confluence of these ideas is, I think, the Palazzetto, the small sports palace that he builds for the 1960 Olympics. In 1957, Rome has decided to compete for the Olympic Games, or to propose that they hold the Games there, as a way of sort of reintroducing themselves back into the community of nations a decade and a half or so after World War II. Nervi is on the committee that is charged with building a demonstration arena to show the International Olympic Committee that Italy is capable of building this many structures this quickly. He helps write the tender, and then he turns around and bids on the tender and is the only bidder. Nervi was not only a great engineer and contractor, he was a brilliant businessman. And this being Italy, everyone sort of turns the other way and lets it happen. And thank goodness, because I think this is undoubtedly kind of Nervi's finest, most distilled work. But as you can see, again, it's in many ways a very simple building. I tell my students that if you wanted to, if you had enough space and enough time, you could almost go build the Palazzo della Sport in your backyard, because it uses exactly the same kind of simple techniques that the Turin hall used. The job site yard on the left, you can see that this crew of 5 and probably about a dozen more laborers has just been making these diamond-shaped tabelloni again and again and again for weeks on end. You can see that they're small enough that a crew of 4 or 5 people can take them across the road to the job site. And on the right, you see them being laid out, again, tiling this domed surface. And there is a tower crane that comes up through the middle that was on site for less than 60 days. So because everything is prefabricated, Nervi is able to limit the amount of time that he actually needs the hoisting equipment for. Concrete was then poured over the surface of this. Where the pans meet in this little brim detail, that will be the ribs of the structure below. And then there'll be a very thin concrete surface that holds it all together off the back. Palazzetto is known for several details, the sort of eyebrows that stiffen the edge of the roof shell, these forked buttresses that very dramatically show you how the ground is going to take up the thrust from the roof. Not shown is a tension ring that's buried just beneath the ground that finally does all of the really hard work. And then on the right, of course, the result of this almost algorithmic process where self-similar shapes are fabricated again and again and again. They're laid out on a rough grid. For a long time, I thought that there must have been some complicated mathematics behind this. And in fact, Nervi just built a sort of plywood form and literally just drew on the form full scale how big he thought these spirals should be. So a great sort of intuition. And as a result, this kind of incredibly captivating space. And I think just like Turin, it's a space where you're seeing two things at once. You're seeing the statics of the span, this kind of sublimely large span in concrete. And yet you are also seeing a record of the individual labors that made it up, right? That sort of human scale gets imprinted onto this otherwise very vast span. The Palazzetto gets called a concrete Pantheon, and one of Nervi's contemporaries makes the point that it's one thing to bring the daylight in from the top of a dome. It's another thing to bring the daylight in from underneath a dome. And if you want to give the Romans credit for building something great, back in 80 AD, you have to give Nervi credit for sort of turning that on its head, right? And designing a dome that's so light that you can actually, literally lift it up into the air and let sunlight and people come in from underneath. Nervi was fond of saying that the dome was literally thinner than an eggshell proportionally. That is, if you exclude the ribs, which to a knowing audience is a fairly big exclusion. But nevertheless, it's a sort of, the section to me is one of the most sublime things Nervi ever did, because it literally feels like it is, the thinnest possible roof you could get away with, and yet made so simply. And this sort of final trick about this building that I think shows Nervi as the sort of contracting genius that he was, is that the roof was built first. And then the seating bowl and all of these admittedly terrible WCs and locker rooms and things that are underneath was all built after the roof was in place, so that they wouldn't be subject to weather. Right? A rain delay wouldn't affect any of the work that was going on actually in the building. So this was done in 1957. It was the largest reinforced concrete dome when it was built, and that was superseded by the other indoor arena that Nervi built for the 1960 Olympics, the so-called Palazzo della Sport, the large sports palace, which is in many ways, I think, a slightly less elegant building because maybe it has more ideas to it. But the fundamental move for the roof was to take the roof idea from Turin and to, instead of doing it as a rotational grid, or instead of doing it as an extruded shape, to actually do it as a rotational grid. So these, you can see, these folded plates are all made of ferrocement again, brought into place by a lightweight crane and grouted to one another around the circumference to form this span that sits on these kind of almost Gothic buttresses, right? These fan-shaped buttresses at the back. Now, interestingly, when Nervi comes around to designing the seating, he almost can't help himself, and he reverts, as you see on the right, to sort of rendering the bottom of the seating bowl in the same ferrocement pans that he's used for the Palazzetto. And I see that almost as a kind of acknowledgement that one system maybe tells you a little bit more, or is a little bit more expressive than the other. The Palazzetto, I think, has aged a little bit better, I think, again, because of its simplicity. But the Palazzo is a building that puts Nervi, again, back on the world stage at age 70 at this point, and he enjoys this kind of second celebrity career. There's a real kind of public, the public's very impressed by these buildings. They see them. The 1960 games are some of the first to be televised, so when America tunes in to see Cassius Clay win the gold medal in boxing, he does it in a Nervi building. And Nervi's reputation sort of takes off, and he becomes this kind of celebrity engineer almost. The Palazzo, just to show just how resonant this building was, right? So here is an engineer working on an incredibly tight contract, right, budget-wise, schedule-wise, who produces something in concrete using mostly kind of unskilled labor in the job site yard. And the result ends up being published in a fashion spread in Vogue magazine a few years later. I don't know how many of you have had your work published in Vogue, but this is amazing, right? And the other thing that has been surprising to me is how often Nervi's buildings show up in Italian cinema of the era. That whenever an Italian director needs a backdrop that shows the kind of elegance and sophistication and sort of modernity of a character or a situation, the Palazzo della Sport shows up, or the Pirelli Tower in Milan, or even this little restaurant in Ostia, the Cursal, shows up in Italian film. So there's something here that goes beyond just being a sort of competent designer, or being able to work with material in a really efficient way. And to close, I want to sort of speculate a little bit on why this actually is, and to build a little bit on Nervi's own written philosophy, which largely comes to us in Aesthetics and Technology in Building, this landscape format book that Nervi published, and that I'm very pleased to say I've been part of a team that has put together a republication of it, so it's now available once again in landscape format. But in this book was the result of the Charles Eliot Norton Lectures in Poetry that he gave at Harvard University in 1961. And this, I think, gives us some idea of just how resonant these buildings were, that an engineer in concrete, someone whose whole career was based on impossible budgets and deadlines, ends up giving these lectures on poetry at Harvard. And Nervi's own philosophy, I think, begins to touch on this. He talks about the idea that architectural beauty and building technology are related to one another, and that the fact that they complement and provoke one another has something to do with his own sort of idea of why he makes beautiful things. And so to close, I want to speculate just a bit. And I feel like if a structural engineer can give the Norton Lectures in Poetry, then an audience of structural engineers, I hope, will put up with me while I talk a little bit about why I think poetry might be the right way to talk about Nervi. And as I do this, I'll show you some images that we commissioned from a German photographer named Hans Christian Schink to use as the kind of gatefold in this republication of Aesthetics and Technology. And he, on his own, came up with the title for this portfolio called The Shape of Beauty. So, given the deeply pragmatic nature of Nervi's approach, it seemed miraculous to contemporary critics that he should have been able to achieve the poetry in concrete that he did. Wrestling beauty from the most unforgiving and unlikely of circumstances is an irresistibly heroic tale, and his status again as a poet in concrete was inevitably mentioned alongside accounts of his project's thriftiness and efficiency. And yet maybe this shouldn't be so surprising given the nature of poetry itself. Its whole point, after all, is to condense moments of beauty out of concise, elusive forms that resonate beyond their meaning or their economy of breath or print alone. The claim of Nervi as a poet may well be more insightful than it first appears. Rigor of beauty is the quest, noted American poet William Carlos Williams in his 1946 epic Patterson, a phrase that I've used as the title to my study of Nervi's processes, and one that suggests that rather than an exultant leap, the poet's quest is really one of diligence. The challenge of poetry is not simply conveying an emotion, it is rather to do so within the constraints of accepted rhythms, meters, and schemes, systems of rules that force choices about words, phrases, and pacing, the expression of feelings and ideas according to one definition that's given intensity by distinctive styles or rhythms. The discipline imposed by these conventions and rules distills, by necessity, emotional content into poetic efficiency. To the listener or reader, the tension between the content of a piece and the rhythms or patterns into which it's refined reward our attention and compel our thought. Our response has to be this dual focus on both the overall impression and the finer-grained grammatic details, a tension that we seem cognitively inclined to seek out and enjoy. Nervi's work combines thrilling spans with intricate mathematical patterning that comes about from its making, from the grammar of construction. His domes, especially the Palazzetto, captivate us by showing us all at once the vast scale of their structural achievement, or the vast size of their structural achievement, and the finely wrought scale of the human labor that produced it. Our minds are caught between the vastness of the overall aspiration and the effort of the individual laborer, between that of the cantiere and that of the actual workman, interpreting one experience through the other. Seeing Nervi's work as poetic in this sense of resonating between content and form, or expression and constraint, or ambition and labor, suggests perhaps why his work seems so much more engaging than other contemporary spans executed without his fluency in the grammars of construction and fabrication. In his short-lived role as architecture critic for Casa Bella, Nervi took designers lacking such fluency to task, in particular Eros Saarinen and Jorn Utzon. Saarinen's TWA terminal, he felt, was, quote, a structure that makes no sense and a waste of money. You can see perhaps why his tenure was short-lived. Even more damning, Utzon's Sydney Opera House was for him anti-structure. When the problem is large, Nervi wrote, man must make himself small and follow the technology. Beauty as an end is not the criterion for structure. Beauty must come from itself. Such an intimate awareness of the job site's economics is also lacking, for example, in much celebrated contemporary work, structurally gymnastic architecture that fails to achieve the deep resonance of Nervi's. I was going to be too polite to mention any names, but since his name has come up, I would put Calatrava into this category. Many of today's dramatic, often biomorphic forms, the heirs of Saarinen and Utzon maybe, are also lacking the fine grain, the rules or the constraints that makes visible their processes of assembly. They are intentionally scaleless, lacking the discipline or rigor imposed by demands of economy or fabrication. Such projects are dramatic and captivating. They're literally sensational in that they arrest our attention and thrill us with often sublime leaps of span and forms that often seem magically precariously balanced. They are, in the classic formulation of aesthetics, structures that provide delight of the senses, photogenic, Instagrammable, visually entertaining. The pleasures of Nervi's projects, though, are deeper. They are structures that provide delight through the senses, experiences that connect us to the principles of physics embodied in structural form, as well as to those of materials, fabrication, and labor that occur in the field. We cannot take in these two complementary experiences through our senses alone. Our minds have to be engaged to understand them in dialogue with one another. And Nervi's fluency in these two languages, of static shape and of constructive grammar, are very much like the poet's fluency in the distinct realms of metaphor and rhythm. When content and form are combined through the hard work of design or writing into a distilled piece of structural or linguistic poetry, we can't help but be drawn into the rich interplay between the two, into the beauty that comes only from a commitment to finding meaning within the often competing constraints of our disciplines. At their best, poetry and engineering extend us as well, making us wiser and perhaps more knowledgeable, either explicitly or intuitively, about the world around us. Nervi's best work does exactly this. It gives us tangible evidence of principles of physics and of the capabilities that we as humans have to form the raw matter that the world gives us into conformance with those principles, lifting, as Shelley said only poetry can do, the veil from the hidden beauty of the world. Thank you.
Thank you very much, Tom. So, time for questions. I'm sure there's going to be plenty. Who'd like to kick off? Yes, so just wait one moment, Ollie.
Julia Elton, aka Mrs. James Sutherland. Actually, you talk about poetry and structure. I had, for years and years, similar conversations with Derek Sugden about music and structure. Because, in fact, we concluded that fugue, I don't know if you're a musician, but fugue is a sort of metaphor for structure, because actually it's full of rules and full of very powerful constraints. And only the greatest masters, of whom Derek and I naturally thought J.S. Bach, is actually inspired by the constraints, by the very strong constraints of the musical form, and is able to move like an eel amongst them in a way that lesser people can't. So could I ask you to add music to your metaphor about structure and poetry?
Done, absolutely. I think that's a perfect example, and I suspect that what's really going on in these three examples is that all of them deal with deeper ways that our mind works, that enjoys seeing patterns, enjoys sort of figuring out rules, but also loves nothing more than watching someone do gymnastics with them, surely.
Thank you very much. That was a wonderful lecture. In the research, did you come across Nervi referring to the geometry of the spirals that he used in the domes? You mentioned the sunflower, and there's obviously apparent similarities, but also some differences between Fibonacci spirals that were present. So I'd love to hear more about that. Thank you.
Unfortunately, his only mention of the spirals is that they're quite captivating. And years ago, the first paper I ever wrote on Nervi was exactly on this, that, oh, these must be Fibonacci numbers. And when I got into the archives and looked at the relationship between the pans, I was expecting, 1, 1, 2, like, and of course, not even close, because there wasn't a mathematical relationship. It was literally Nervi saying, well, here's how big the thing is. I guess it'll be about, like that. And all he ever writes about it is, yeah, those are pretty captivating. To me, there are reasons that the spirals show up. They're not true logarithmic spirals. They're off, and if you look closely, you can see that the rhythm of the pans, they should get smaller in a very predictable way. And they don't. The ones at the top are actually much more attenuated than the ones at the base. So he's faking it. But it's close enough, and I think it has to do with the almost self-similarity of them, that you get these things that look like logarithmic spirals.
For me, the most beautiful moment is between the curve becoming straight in the central part of the dome.
And the most beautiful moment is the curve becoming straight. This is absolutely true. And there is this kind of grace note, if you like, of the last couple of pans just getting combined into one very, very long, skinny piece. And I'm sure there are fabrication reasons for that, right? At some point, you can't build a ferrocement pan small enough. But it also, I think, just does kind of, tail out the rhythm just enough. And that, to me, I think, is intuition as much as anything else.
Thank you, that was brilliant. It was clear that a lot of the beauty came, or all of the beauty came from the constraints that were around at that time and that he had to work with. How do you think he would design today, and what materials and techniques he would use within today's constraints?
This is my favorite question of all time. What would Nervi do with Grasshopper? And I suspect that I'm not smart enough or fluent enough in that language to know exactly. But one thing that I think he wrote about occasionally was that the constraints of fabrication and construction occasionally left him limited in form. That the dome of the palazzetto is a sphere, part of a sphere, which is easy to build, but of course is not that great for static purposes, right? You'd like it to be taller, you'd like it to be a more pure structural shape, but Nervi has no way of kind of drawing that or building it. I suspect you would see more adventurous forms. I don't think they would be, I think they would still be held to principles. I think they would probably conform more to more complex structural shapes because he would be able to, mass customize things like ferrocement pans and things like that. It's interesting, when I first started working with student teams to build some of the models from which the drawings came, I had this absolutely brilliant student from Iran who said, we're going to just put the whole thing in Grasshopper and hit a button and it's going to build itself. And we could never get it to work. And after 2 or 3 months, she said, I've realized something, which is that we're being too smart. And we need to go back, we need to find software that's actually a little dumber. And it turns out that all of the models are SketchUp, because SketchUp mimics so closely that kind of almost dumb, just like repetitive, like make one shape and multiply it 100 times. And that to me was a realization that, yes, there were limits to the patterning and to the shapes that Nervi was able to make.
I still vividly remember picking up Nervi's book when I was a student in the 60s. And I'm just thinking about the things you said this evening and about the constraints. And I just have a feeling, actually, that in the limit, there was one constraint that made his work possible, and that is the intersection of economy and ambition from the politicians, which we wouldn't have anymore. So they want to have the Olympics, they have to build a stadium, they can't afford it. Someone comes along and says, I can do this, and nobody says, hell, nobody's done anything like that before, we daren't try that.
Right.
We've got to do it. And I think that's a big difference that someone had in the 50s and 60s over where we are now.
I think that's an important point, that Nervi was also, he had clients who believed he could do the work and who largely sort of hired him because they wanted him to do the impossible, but he had not necessarily the financial or the constructive resources, but he certainly had the political resources. And there's a great book to be written on the whole history of the 1960 Olympics because its ambitions were phenomenal. I mean, Nervi builds this series of arenas, but they also convert parts of the Roman Forum for Greco-Roman wrestling. And they very frankly used a lot of fascist monuments as well, as a way of saying, we're not hiding anything, this is, what our country's history is. It was certainly the most ambitious games up to that point, and to your point, I think in hindsight, conceptually, maybe the most ambitious ever, for sure.
Hello, Roger Widstow-Smith from Foster & Partners, and thank you very much for that talk. My question is, I've never really understood how Nervi related or interacted with other shell designers of that period. So the Germans and what was going on in America, Tedesco, people like that. I wonder if you could shed any light on that, please.
Surprisingly little interaction. He certainly mentions Torroja and Candela and the sort of pantheon of shell builders. But he was a little older. If I've got the math right, he was older than they were, and I think he saw them more as students than anything else. His process was so sui generis. I mean, it couldn't have been replicated, in a even slightly different economy or with a slightly different setup. And while he was certainly interested, there's very little record of him, corresponding with any of these folks or going to conferences. He liked building things, and he was sort of happy to do that. He spoke, in addition to Italian, he spoke French and almost no English. And in the correspondence, you do occasionally hear him talk about, well, I would love to come do that, but my English will hold me back, and I'm not so interested. So even then, 50 years ago, English as the lingua franca for academia and for engineering had its effects. And I think I don't know that Nervi was necessarily a casualty of that, but it was part of his kind of isolation, I think, from some of the other currents at the time.
The images that you showed of his hangars at Orbitello reminded me of footage that I've seen of Freycinet's hangars at Orly, and I wondered if there was any dialogue between them. And secondly, just the kind of visual sensibility that's shown by Nervi, by Torroja, by Candela. Whilst you say that you saw no three-dimensional drawings or whatever, and there weren't any big declarations about it. It certainly seems to be very strong. I wondered if you found anything about a visual formation in his education or in his background or in his family that would have that he would have drawn upon.
Yeah. Well, to the first part of your question, Freycinet was someone that he saw as an influence. I think in many ways, that's the way that the Orly hangars were constructed was something that he was reacting against out of necessity, right, to break that down into more efficient shapes. The kind of uncanny visual nature of his work, I really believe almost came out of nowhere. He had no aesthetic training, no architectural training. He made one of his sons go become an architect because he needed a architectural license in the firm. but his background was entirely engineering. He had a very good eye. He and his wife were sort of minor art collectors, and he could certainly pick a good painting. And I think also, he loved Gothic architecture. He loved classical architecture, and he did write about being obsessed with going to see some of these things. So some of that, I'm sure, you pick up from a lifetime of looking at these, but so did lots of other people in Italy in the early 20th century, and not everyone ended up with that sort of sensibility. It is really uncanny to me. As an architect, I went in expecting, brilliant perspectives and, even just like elevations. But, you got the sense that he worked out the process and sort of, left the project through the front door, right? Like, just sort of clad the thing at the end. And I think one of the reasons, for all the difficulties of construction, I think one of the reasons he liked domes is that there wasn't a big architectural elevation to it, right? You got the process down and it was self-contained and you didn't have to worry so much, maybe.
It was a wonderful lecture. Thank you very much. I remember going to a talk about Candela many years ago, and he was asked about the weathering of his buildings and how they coped with such low cover. And I wondered, his response was, we don't have building regulations in South America. But I wondered, with Nervi's buildings, how they've weathered externally, or what protection they had.
Yeah, poorly, for the most part. And some of that is due to the techniques themselves, that when you make smaller elements, you have more joints, and so there's more opportunity for water to invade. But a lot of it, too, is maintenance, and a lot of the work in Italy, especially, sort of lived its life and then was either partially abandoned or just not kept up well. The Palazzetto had a very ill-intentioned coat of waterproofing put on it and then taken off of it, which is why you see what looks like kind of mold and things on it. It's actually adhesive from the waterproofing surface. There are some small victories. The Stadio Flaminio, I've been part of a team that's campaigned for its rehabilitation into a neighborhood center. And the city of Rome, just in the last few weeks, has started moving toward doing that. So we're hoping that if some of these buildings get re-inhabited or reconceived, that then the money comes along to actually take care of them. The one that's a real crisis right now is not one that I showed, but the Palazzo Lavoro in Turin, which was built for the 1961 centenary, and it has 16 giant mushroom columns and a really elegant steel and glass curtain wall around the outside. And it's been abandoned literally for 30 years. And there was a large fire in it a few years ago. There'd been a homeless camp, and someone had lit something on fire, and the building very nearly was condemned. And that right now is the one that's kind of in the most danger. The other ones, for the most part, are still standing and still okay, but some of them are getting desperate.
Thank you, that was amazing. And for me, one of the really amazing things about it was the apparent disjunction between the apparently wonderful precision of these structures. And you think, and actually in the modern world, you think, yes, well, that was an amazing program that was designed with. And there's Nervi sitting at his drawing board. Right. And there's this workshop with about a dozen guys making these things and carrying them on wheelbarrows. And I'm thinking, what sort of tolerances is he working to? And how do you know everything was going to fit? Right. You'd think structures like that are going to require millimetric perfection, but that's surely not possible given the kind of technique he's working to. I just can't get my head around this at all.
Yeah.
You think of Bureau Happold and Foster's putting the roof over the great court of the British Museum, superficially similar, And they say every single panel's a different shape or something, and there's this huge computer program to build it. Obviously not similar at all.
Right. The problem of tolerance was a huge one. You see evidence that he knew the tricks. So, for instance, the palazzetto, the tiles, when they come together at the sort of bottom of the rib, there's about a 20 centimeters, an inch or so gap between the two. And the idea was that that would allow you that much kind of play. And then, once you disarm the scaffolding, you just come back and plaster the gap, right? Which makes the rib seem perfectly smooth. So I would have loved to have gotten up in a, bucket and sort of poked around, but my guess is that those tiles probably move around quite a bit. And it's the continuity, your eye makes them seem perfectly continuous. But in reality, there must have been extraordinary tolerances that they had to accommodate.
Hi, Nikolai. Thank you for the amazing lecture. Just wanted to say more than a question is just continuing on the thing about making effort when we need to make effort like to realize these big structures. And just because I'm from Italy, it happened like in 2009, we had to host the World Swimming Championships. And because it was cited before, all the works, the main architect was Calatrava. Mm-hmm. And it was fascinating to see how fees almost doubled, and most of the structure weren't completed by the time they were to be completed, and almost all the championship were hosted in the old buildings, like from the 40s, from the fascist era. So it's amazing how Nervi in the 60s, almost 50 years before, was able to do these works. And also I think this is the main difference between Calatrava and Nervi, if you want, just because as you always pointed out, many times pointed out, we have to remember about the human scale of Nervi's work. Even though you have these majestic structures, this big structure, Calatrava was not able maybe to achieve that, or maybe wasn't even interested to achieve that. So yeah, interesting story to see, and it would be even amazing to see how they gathered and they made it realized in the 60s. All these works.
The Calatrava thing is this unfinished ruin that's on the edge of the city, and it's sort of fascinating in its own right. But it never opened. I don't think it's ever been used. And Nervi, to his credit, he completed projects, right? There are very few that were abandoned, and certainly none that were abandoned because of cost overruns or schedule problems.
Right, I think we've got time for a couple of final questions. I think there was somebody at the back had a hand up just now, and there's one here at the front.
I'd like to know how can we encourage our clients to buy these things?
I did mention I'm an academic.
We have to persuade in some way, right?
Well, all of the buildings I've shown were low bid tenders. And, to me, the real genius of Nervi's practice was that he won these commissions by underbidding his competitors. He was the cheapest contractor for a long span building anywhere in Italy. Sometimes to the point where, today we would look back and say it's slightly unfair competition. But he, only after 1960 did clients come to him because they wanted a Nervi building. Up until then, until he's 70 years old, he wins almost all of his jobs by doing it for less money than the other firms. Sorry, I'm sure that's not the answer you were looking for.
Well, it is the wedding between the construction and the isn't it? That's the important thing. Yeah, the fact
Right.
that he knew the details, he knew how to deliver. And I think sometimes we get caught up in contracts and we forget that we actually do need to be a bit closer joined at the hip. And that is something that I think we need to improve on now. And I think he obviously mastered it very well.
Yeah.
So,
And fair point. I think one of the really pragmatic lessons is that, the closer design and execution are to one another, the more likely you are to realize efficiencies, to make smart decisions, to achieve buildings that are wound a little bit more tightly than I think people, designers all over the world are sort of used to working.